So let's learn a new concept of mathematics which is called as Simpson's one-third rule. So here, to learn the Simpson's one-third rule, let us understand why do we use the Simpson's one-third rule. So Simpson's one-third rule is basically used to find out the value of definite integration. So Simpson's, basically the Thomas Simpson's is a scientist which is now popularly known as Simpson's rule. So we say that Simpson's rule is invented by Thomas Simpson's. But let me tell you that before the Thomas Simpson's, this rule was discovered by Johann Kepler, and it was been used for 100 years. But now we know it by the Simpson's name. Now in Simpson's one-third rule, basically we are going to use the method of statistics, where by using the values of certain intervals we are going to get the value of definite integral. Now guys, in definite integral we know we have upper limit and lower limit like this. Let's say we have from a to b f of x dx. So if we know the intervals or subintervals between a to b, then using those subintervals we can find out the value of f of x at each and every subinterval, and then we can use the Simpson's one-third rule to evaluate the integration. Now to evaluate this, what is the formula? So the formula is like this. It is h upon 3 x plus 2e plus 4o. Now guys, what is meaning of each and every term? So here I'll say where h is nothing but the difference between interval or difference between subintervals, that would be the proper word. So see, now we have the start point or the initial value of x as a and the last value of x as b. So in between these 2 points we will be taking intervals or subintervals. So the difference between any two subintervals must be same, and hence we call that difference as h. Then we have x. So x is nothing but it is the sum of extreme ordinates. Now extreme ordinate is nothing but the y coordinate, because we call the x coordinate as abscissa and y coordinate as ordinate. Now how do we get the y coordinate? So guys, here we have function f of x. So whenever we put any value of x in f of x, we get the value of the function at that point. So here similarly, to get the value of f of x, I am gonna put each and every value of subinterval at x. So by doing that, I'll get multiple values of f of x at each and every subinterval, or I would say one value of f of x at each subinterval. Now guys, that value of the function f of x is called as y, and which will be called as ordinate. So here ordinate is nothing but the value of function f of x at point x or at a particular subinterval. So here I'll say capital X is nothing but sum of extreme ordinates. Now guys, when I say the extreme ordinates, so it means the extreme points of the curve, and here we can see it is a and b. So I'll find out the value of function f of x at a, then value of function f of x at b, and then by taking these two values or by adding these two values, I can get the value of x. Now what is e? E is nothing but sum of the even ordinates. So sum of even ordinates, here I'll say. Now guys, how to get this even ordinate? So see, whenever we'll find out the value of function f of x or value of y at each and every value of x, we'll get values like this. So first value will be called as y0, then y1, then y2, then y3, y4, and so on. So what we have to do is we have to take the sum of even ordinates. So I'll take one example. Let's say I have these many values. So now y0 and y6 is been covered in sum of extreme ordinates. So in sum of even ordinates, we'll take the remaining even terms. So now the even terms are y2 and y4. So I will add y2 and y4 and we'll put it here at sum of even ordinates. So or whatever value that we are getting, that will be called as E. Now what is O? So O means sum of odd ordinates. So it is sum of odd ordinates. Now guys, again the same concept, extreme ordinates are gone. Let's say even y2 and y4 are gone. So what is remaining? y1, y3 and y5, and 1, 3, 5 are the odd numbers. So sum of these odd ordinates will be called as O. So by putting all these values in the formula, we can get the value of definite integral by using Simpson's one-third rule. Now guys, to use this formula or to use this rule, there is one condition which you all have to remember, and that condition is the number of subintervals must be even. Now what does it mean? If you'll see here, then how many subintervals we have? So here 1, 2, 3, 4, 5 and 6. So subintervals are 6. So it is accepted because 6 is even number. So number of subintervals must be even. Now how to remember this thing? So the best idea is you should observe the last ordinate. If this last ordinate is even, then automatically the number of subintervals are even. So here we should have the last subinterval or last interval as y6 or y8 or y10 or y12 and so on. So we should have the even number in the end. And if we have the subintervals or the even subintervals, then only we can apply the Simpson's one-third rule. So you just have to remember this condition in your mind, and by using the Simpson's one-third rule, you can solve many numericals. So I'm sure that you have understood the Simpson's one-third rule and you want to learn more numericals on Simpson's one-third rule. So keep watching videos. We'll meet in the next video where we'll learn the numerical based on Simpson's one-third rule. Thank you very much.